In this video, we're going to look at light. We're going to cover some of the properties of light. We'll then look at reflection and refraction. So light is electromagnetic radiation that we perceive with our eyes so that we can see. We call it visible light, or the visible spectrum of electromagnetic radiation. And this occurs between 390 nanometers, which we perceive as blue or violet, through to 700 nanometers, which we perceive as red. Now, light moves in straight lines as it goes through a medium. However, when it moves from one medium to another, it can change speed. So it has a constant speed in a vacuum, but in a different medium, it can have a different speed, similar to how sound changes speed depending on the medium it's in. Light changes speed as well. And this amount of change in speed we refer to as optical density. So mediums that are more optically dense, it's slower for light to travel through. When light bounces off an object, we call it reflection. Now, when we measure angles, we always measure from the normal. So the normal is a line perpendicular to the object or the medium that it's interacting with. So this is the normal. The incident ray is the ray that's coming in, and the angle of incidence is the angle between the incident ray and the normal. When that incident ray hits the medium, and in this case it's going to be a mirror, it gets reflected. And it is reflected, so we've got our reflected ray here, and the angle of reflection is the angle between the reflected ray and the normal. And for reflection, the angle of incidence will equal the angle of reflection. So that was just for one ray. For a smooth object, for example a mirror, all the rays, the incident rays that come in, will be reflected clearly and in order. And we call this specular reflection. If, however, the surface is rough, and this doesn't have to be, don't have to be able to feel that it's rough. Sometimes they'll be rough on a microscopic level, even though they feel smooth. The rays will be scattered, so they'll all come out higgledy-piggledy, and we call this diffuse reflection. Refraction occurs when light passes from one medium into another, and the mediums have a different optical density. This causes them to change speed. So if a ray is coming from a less dense medium into a more dense medium, it's going to slow down. And as it slows down, it bends towards the normal. So that means that the angle of incidence is going to be larger than the angle of refraction. Conversely, if we're going from a medium of high optical density, like glass, to a medium of low optical density, like air, the ray is going to speed up, and that speeding up will cause it to bend away from the normal. So here, the angle of incidence is going to be smaller than the angle of refraction. This bending or refraction is why, when we're looking into water, objects appear to be shallower than they actually are. And this is because the ray that's coming from the sun or wherever the light source is and bouncing off the fish into our eyes gets bent as it moves from the water to the air. And our brain isn't wired to cope with this bending because the rays generally travel in lines. What the brain does is perceive that this ray traveled in a straight line, and therefore tricks the brain into thinking that the object is higher or shallower than it actually is. And just like reflection can either be specular or diffuse, if a refracted surface has parallel sides, so for example a plain glass window which is flat on both sides, the image will pass through clearly. And that's why we can see through a window. If they are not parallel, the image will be distorted. And so this might be in the shower screen, which has a textured glass, which is usually flat on one side, but wavy or bubbly on the other side. And this stops the image from traveling through the glass clearly. In this video, we've looked at light being electromagnetic radiation in the visible spectrum that travels in straight lines. We've looked at reflection, where the light waves bounce off a medium, where the angle of incidence equals the angle of reflection. And we've also looked at refraction, where light passes from one medium to another with different optical densities. And when it's going from a less dense to a more dense, the refraction will be towards the normal. And when we're going from a more dense to a less optically dense medium, the refracted ray will move away from the normal.